Welcome to our first video for Year 9 Physics, and we are going to eventually cover sound, light, and heat, particularly with details such as what are they from a physics standpoint, and also how they sort of propagate, how do they transfer through materials, or how do they get from A to B. We're going to begin this short couple of videos, maybe a bit longer. We're going to focus on sound, but I thought we should probably make a visual link here that we're going to work on waves. If you understand the theory of waves, you'll see that it relates quite closely to sound waves and also about light waves. And to a small extent, in one particular case, waves are related to how heat propagates, how it moves through space. So we've got to focus on this theory, this concept first. And I've broken it down. It's very simple. We've got two types of waves. We've got transverse waves and we've got longitudinal waves. I'll talk about this one here a bit in a moment. We're just going to focus on this one here. Transverse waves are the ones you've seen every day in your life. When you see like ripples across the water surface, that is a transverse wave. So if you can imagine, I've got a bowl of water and I filled it with some water, and if I flick the edge of the bowl, you'd imagine that the bowl would vibrate and then it would send ripples across the surface of the water. And they would move from this side where I flicked it all the way to the other side. And you got the little ripples happening over the surface. Now, that's something we're going to point out, is that this rippling nature seems to travel, let me use a different color. The wave travels in a particular direction of those undulating waves, yeah? Little height and valleys and stuff like that. So as I flick the bowl, the water ripples happen and they seem to be moving this way. But what you don't know, or at least what is not obvious, is that what causes these undulations is not particles moving left to right. It's actually the particles of those water molecules. They're moving up and down, up and down, up and down, roughly in the same place that they were. And I'm just illustrating this in the little 3 lines here below. So if you can imagine, this line here is a piece of skipping rope or just rope. And if I give it a bit of a wiggle, a flick, you'll get like a hump. And if you leave it long enough, it'll just eventually work its way to the end. This is what the 3 different lines here are. So start, and then in the middle, and then eventually it'll reach the end, and then maybe it dies off on the side. What's actually happening is that your rope isn't physically moving that way, although the wave seems to be. What's actually happening is that the rope itself is moving up and down. So here, this part of the rope is moving up. The bit of rope just happened before, it was moving down. This part of the rope is moving up. So this undulation that we see every day is caused by the particles. So if you can imagine, this rope is made out of a series of particles. They are just happily moving up and down. They are not moving side to side. That one there is not as useful as this one here, longitudinal waves. I'm not sure how clear it is on the video. I've tried my best, but can you see that looks like a sort of a scattering of dots across this bottom of the page? And in some regions, I hope it's obvious that you can see sort of regions here where it's a bit more densely packed here, a bit more dense spots over here, and here, and here, and here, and here. And then there's some spaces in between which has very few dots. That's exactly what a longitudinal wave is. It's where you've got compressions where the particles are really bunched together, very close together. And then you've got spaces in between which have very few particles in that space, so it's it's less dense. And then it's got another region nearby which has another sort of compression of those particles together, and so on and so forth. This is what sound waves are. They are compressions, and these little not vacancies, but less dense regions, those ones there are called rarefactions. I'll just write that for a minute here. So this is called the compressions. So every time it bunches up, that's called a compression. So I'll put arrows on them as well. The spaces in between, which have relatively few particles in them, that is the rarefactions. It's a very strange word. So how does this relate to sound waves? I'm going to cut the video now and I'm going to flip over the page and draw up some new notes.